Neutron stars are some of the most exotic objects in the cosmos. But how do they form? How common are they? Why are they called neutron stars? And what makes them different from other stars? Let's find out, shall we? Neutron stars have up to twice the mass of the Sun crammed into a volume that's no bigger than a typical city. Their gravity is so intense that it bends light in the path of a circle, meaning that light can actually orbit a neutron star. Their density is so extreme that a handful of stuff from a neutron star would far outweigh a mountain on Earth. The extreme gravity means that the tallest hills on a neutron star are only like a centimeter high. If you were to fall off one of these so-called mountains, by the time you hit the ground you would be traveling at a good fraction of the speed of light. Neutron stars are the densest objects in the entire universe. They're so dense, in fact, that if they were even a tiny bit denser, they would collapse to become black holes. Neutron stars are what you get after the death of a giant star, at least 10 times the mass of the Sun. Towards the end of their lives, those giant stars build heavier and heavier elements in their cores, all the way up to iron. But a star can't gain energy from the fusion of iron, and so the whole star begins collapsing. In less than a second, the incredible pressures shove electrons into atomic nuclei, converting protons into neutrons. This leaves behind the solid mass of neutrons, which can temporarily halt the collapse of the star. This triggers an ensuing supernova explosion, which leaves behind the core. That exposed core is now called a neutron star. The power from the supernova that birthed it gives the star an extremely quick rotation, causing it to spin several times in a second. Neutron stars can spin as fast as 43,000 times per minute, although they do slow down over time. While there are probably about 1 billion neutron stars in the Milky Way, astronomers can't see most of them because they are relatively small and dim. When they first form, they have a temperature of around 500,000 Kelvin, but they quickly cool off. Sometimes neutron stars collide, and when they do, they are responsible for an explosion known as a kilonova.